Welcome to The Explainer. Today, we're diving into how factories are making a massive leap from just being dumb muscle to becoming thinking factories. But what does it really mean to make a machine smart?
You hear the term Industry 4.0 thrown around all the time, right? Well, this is the core question behind it all. And the real difference between an old-school factory and a truly smart one? It all boils down to one single critical upgrade.
And here it is, plain and simple. Think of a traditional machine as just the muscle. It's got a basic controller, yeah, it makes it do stuff. But a smart machine, it's got the muscle plus the brain. And it's that brain that completely changes the game, letting it think, talk to other machines, and even change what it's doing on the fly. So every machine out there, smart or not, has this muscle. It's called a PLC, a Programmable Logic Controller. This thing is the absolute workhorse. It handles all the basic physical actions. You press a button, a motor starts. It's all about simple commands like on, off, start, stop. It's super important for sure, but it doesn't do any real thinking. Okay, but this is the real upgrade. This is the brain. It's called an IPC, an industrial PC. What you're doing is literally strapping a rugged, powerful computer right onto the machine. This brain can handle way more complex stuff, talking to other systems, crunching data right there on the factory floor, and following some seriously advanced instructions. It's what turns a simple tool into a thinking partner. So what's the big deal? What does adding a brain actually get you? Well, let's take something like changing what a machine is making, a recipe change. With a traditional machine, you gotta shut the whole thing down. Someone has to go over and tweak it by hand. That's downtime, and downtime is lost money. A smart machine, it can switch from making one product to another just like that, on the fly. It's no longer this lonely island on the factory floor. It becomes this connected hub you can manage from anywhere. And it even starts to think for itself by processing its own data. All right, so now all our machines have brains. Awesome. Except we've just created a brand new problem. Imagine a factory where every machine speaks a different language. It's chaos. The source material calls this the 8-Nation Alliance, which is just a perfect description. You've basically built a high-tech Tower of Babel right on your shop floor. So how do you fix a Tower of Babel? You need a universal translator. And that's exactly what happened, though it took a few decades. In the 80s, it was total chaos with all these proprietary protocols. Then in the 90s, things got a little better with early standards like Modbus TCP. But the real game changer, the thing that brought us into the modern era, was OPC-UA. This is it. This is the universal language for Industry 4.0, letting every single machine speak the same dialect securely. Okay, so problem solved, right? All our machines are speaking the same language. We're done. Well, not so fast, because now we face a much more subtle but even more important question. Just because they can talk, how should they talk to each other? And the answer to this is the real secret sauce behind what makes a smart factory so incredibly efficient. This analogy is just perfect. You've got two ways to communicate. There's the old way, the polling method. That's like being that annoying friend who keeps texting, "Are you there yet? How about now? Are you there yet?" It's constant, it's noisy, it's inefficient. Then there's the smart way, the event-driven way. That's just getting one simple text, "I'm home." Bam. The information you need exactly when you need it, and nothing else. Let's break that down a bit more. With polling, the main system has to constantly pull information. It's always asking every single machine for its status. This clogs up the network like crazy. And you know what? You can actually miss stuff. If something happens real quick between the times you ask, you'll never even know it occurred. But with an event-driven system, it's the total opposite. The machine pushes an update only when something important happens. The main system just listens. The network load is super low, and you're guaranteed not to miss a thing. Let's visualize this. This is how that inefficient polling method plays out. You've got the MES, the factory's main brain, and it's asking the network, "Hey, is that job done yet?" The network then has to go ask the machine's little PLC controller, "Is the job done?" The PLC just says, "Nope." And this whole ridiculous loop repeats over and over and over until finally it gets a yes. Now, contrast that with the smart event method. It's so much cleaner. Look at this. It's just a simple one-way notification. The second the process is finished, the machine's own brain, the IPC, says, "I'm done." It sends one single event notice that shoots right up the chain to the main system. It's direct, it's instant, and it is beautifully efficient. And that right there is the key shift in thinking. These events, process start, process end, they're not just random bits of data anymore. They are the actual nerve impulses firing through the factory's nervous system. And this gives the manufacturing brain, the MES, a crystal clear live feed of exactly what's happening, second by second. So why go through all this trouble? What's the final payoff? Well, it's massive. First off, your main system isn't burning itself out just asking for updates all day. The error rate drops like a rock because the messages are so clear. Process end means process end, not just some generic on signal. You stop losing data that falls between the cracks, and the bottom line is you get precisely the right information at the exact moment it matters. And to really bring this all home, the source material pulls out this brilliant quote from Sun Tzu. Just as water retains no constant shape, so in warfare there are no constant conditions. A smart factory is like that water, or like that heaven-born captain. Its power isn't in being rigid and strong. Its power is in its ability to adapt and respond instantly. And you simply cannot have that kind of incredible adaptability without this responsive, event-driven nervous system we've been talking about. And that really leaves us with one final provocative question. Take a look at your own operations. Is your factory just collecting data, or is it actually having a conversation? Because that's the real journey here. The move to a truly smart factory isn't just about grabbing more data points. It's about building a system that can have an intelligent, meaningful, real-time conversation with itself. Thanks for joining this explainer.